All right, got a little quest here, going over some problems. Finishing up part 2 of solving quadratic equations using the quadratic formula. Although in this case, we're using a piece of the quadratic formula, which is the discriminant, which is just the plain old b squared minus 4ac. And so, tell you what, let's set this in standard form. Add 18 to both sides. X squared minus 12x plus 18 equals 0. Oh, you know what I'm going to do before I take my A, B, and C? I'm going to divide everybody by 2. Who wants to... Like, what? You don't have to do this, but... Hey, smaller numbers. Right? Ooh, actually, wow. This is factorable. I can have one solution. Ooh. A equals 1, B equals negative 6, and C 9. So let's b squared minus 4ac. Throw that to the discriminant. Negative 6 all squared minus 4 times 1 times 9. 36 minus 36 is 0. So that means there's only one real. Right? If it was equal to a positive, it means there's 2 real solutions. If it was equal to a negative, then there are no real solutions because they're both imaginary. By the way, the reason I suspected that there was only one at this point is because that was a perfect square trinomial. A squared minus 2ab plus b squared. The suspicion. Okay, find the number of x-intercepts. Notice number of. You're not finding the actual x. So let's see. I'm going to set y equal to 0. Negative 6x squared plus 3x 4. X-intercepts occur whenever y is 0, and that's why I that. So a equals negative 6 equals 3 equals negative 4. Plug that into the discriminant. 3 squared minus 4, or b squared minus 4ac, yep. 4a. And so I've got 9. Rip neg, 3 negatives, so there's 2 that pair to be positive, but 1 left over. And 4 times 6 is 24, times 4 is 6. And uh-oh, that's going to be negative. What is that? 87. And if the discriminant is negative, there are no real solutions. And yeah, they're both imaginary. Good. Let's see. Solve using any method of your choice. So okay, this one, I'm thinking this one looks like a quad formula. Because there's a leading coefficient that isn't 1, and it doesn't look easily factorable. Don't want to use complete square because of this, and the b term's odd. Yeah, quad form. Not a fan of quad form though. It's a lot of. All right, so here, I'll write A, B, and C. It's possible someone's logging in just to watch this video. Haven't been doing quadratic formula. Rest of the time, I'll write it down. Here we go. Quadratic formula goes a little something like this: x equals the opposite of b plus or minus the square root squared minus 4ac all over. And so yeah, I'm about to be reaching for a calculator real fast. 169. Trip neg, so 1's negative. 4 times 4 is 16 times 10, hundo 60. Oh, nice. Yeah, this problem was factorable, but it wasn't immediately obvious. So that's the square root of 9 all over negative 20. Did I give myself enough room? Not. Negative 13 plus or minus 3 all over negative 20. All right, so what are my answers? X equals negative 13 plus 3 is negative 10. Negative 10 divided by negative 20. Positive a half. Negative 13 minus 3 is negative 16. Negative over negative is still positive. 16 over 20. 4 goes into both of them. So fifths. Boom. And yeah, the fact that these had no radicals in them left over, it meant that the original problem was technically... All right, this one. Oh, complete the square would be fine. Oh, you know what? Oh, guys, they almost tricked me. I was like, oh, this is factorable though, and it's close. It's close, right? Because if I had this, I would have had to find the factors of 5, but those don't subtract to be 6. They add to be 6. So close. Let's see. Undo, undo, undo. So I'm going to complete the square. Why am I doing that? Because the leading coefficient is 1, and the middle term is even. So rather than, yeah, let's do this. So find a new C term. So new C is equal to B divided by 2 all squared equals 3 all squared. And I told you this was a good last lesson because it ends up reviewing the whole chapter for us, really. So I'll add 9 to both sides. So x squared plus 6x plus 9 is going to equal to 5 plus 9. And so I added 9 to both sides. This I can fast factor. I've got x plus 3 all squared equals 14. Now, this x plus 3, by the way, I fast factored it. I was using a pattern, but the way you do it is take the b, divide by 2. Or it's always going to be the thing you had right before you squared it. And now I can root both sides, plus or minus. Don't forget it. I get x equals plus. And then subtract 3. And I'll leave the answer exact. They didn't ask me for approximations, so I won't give it to them. And square root of 14 didn't reduce. Okay. All right, this one looks factorable. Oh, I know why I chose. I was like, why am I doing so much of your homework for you? I'm just gonna, I know why. Because, man, I had to remember full vacation before it happened. I was just gonna explain which method I would use. This one, factor. I'll let you guys take it away. And this one over here, it has a b term, so I can't use roots. I don't feel like factoring that when I after I subtract 17 sides. The leading coefficient is not 1, and the middle term is odd, so I don't want to complete the square, meaning quad form is the best way. Quadratic formula. Boom. There you go. All right, well, thanks for watching. All y'all, have a great day.